sklearnfeatureselectionchi2. Description: explain in detail. The chi-squared test is a statistical test used to examine differences in categorical variables. In feature selection, it is used to assess the dependency between features and the target variable. The idea is to identify features that are statistically independent of the target, which are likely to be irrelevant for prediction. Inputs: X, a NumPy array or pandas data frame containing the features. Each row represents an instance, and each column represents a feature. Y, a NumPy array or pandas series containing the target variable. It should be a categorical variable. F score, a NumPy array containing the chi-squared statistics for each feature. Higher values indicate stronger dependence between the feature and the target. P-value, a NumPy array containing the p-values for each feature. Smaller p-values indicate that the feature is less likely to be independent of the target. Steps: calculate the observed frequencies for each feature and target value combination. Calculate the expected frequencies under the assumption of independence between the feature and the target. Compute the chi-squared statistic for each feature using the observed and expected frequencies. Calculate the p-value associated with each chi-squared statistic. Chi-squared statistic, a measure of the difference between observed and expected frequencies. Higher values indicate stronger dependence. P-value, the probability of observing the observed frequencies if the feature and the target were independent. Smaller p-values suggest dependence. Heat map of the chi-squared statistics, with features on one axis and target values on the other. Scatter plot of the chi-squared statistics against the p-values. None. The chi2 function does not have any tunable parameters. Confidence intervals for the chi-squared statistics. Bayesian methods to estimate the posterior distribution of the chi-squared statistics. Challenge 1: features with many categories can have inflated chi-squared statistics. Sample use case that resulted in challenge 1: a feature representing a user's location with many possible locations. Fixes to challenge 1: consider using feature engineering techniques to reduce the number of categories, or use a different feature selection method that is less sensitive to the number of categories. Challenge 2: features with low frequencies can have high p-values, even if there is a dependency with the target. Sample use case that resulted in challenge 2: a feature representing a rare disease with a small number of instances in the dataset. Fixes to challenge 2: consider using a different feature selection method that is less sensitive to low frequencies, or use techniques like oversampling or undersampling to balance the class distribution.